important theory and objective questions for your ABM. So watch the series till the end. Okay, let's start. When the items included in a sample are based on the judgment of the individual conducting the sample is said to be non-random. Is it true or false? We are talking of this A1 now. A. When the items included in the sample are based on the judgment of the individual conducting the sample is said to be non-random. What do you say, guys? Type in the comment section true or false. I want the answer only in true or false. Individual conducting the sample. Judgment of the individual conducting the sample. So it is. Yes, 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 it is. Correct. The answer is here. Individual conducting the sample. This is a type of non-probability sampling. So the answer for this is true. Okay. The answer for this is true, everyone. Okay. One sec. Yeah. So the answer is true over here. Let me mark it over here. True. Okay. Second one. A statistic is a characteristic of a population. Now this is a simple one. You must answer this. A statistic is a characteristic of a population. True or false? What do you say? Statistic is a characteristic of a population. Let me see. Everyone, think over it. What is population? What is sample? Suppose if I find the mean of population, what is it called as? Suppose if I find the mean of a sample, what is it called as? Mean of a sample is called as statistic and mean of a population is called as parameter. So what does it mean? A statistic is a characteristic of not a population, but it's for the sample. So this answer is false. Okay, false over here. Okay, got it, everyone? Answer is false. Next one. See, such questions are asked to you in the exam and you need to be very clear in your mind about it. A sampling plan that selects members, from a population at uniform intervals in time order or space is called as stratified sampling. So sampling plan that selects members from a population. So at uniform intervals, this is an important word over here, uniform intervals. So the sampling plan which selects the members at uniform intervals is called a stratified sampling. Is it true? Type fast in the comment section. True or false? What do you think? True or false? True or false? Yes. It is called as true or false? True, false. Yes. Firstly, what are the types of samplings? Probability samplings. There are 4 types of probability samplings. What are those? One is simple random. Yes, type in the comment section. One is simple random. Second one is, yes, everyone. In the comment section, please. Yes, yes, yes. One is simple random. Second is systematic. Correct. Systematic. Second one. Right. Third one, stratified. Correct. And fourth one, cluster. Got it? So here this stratified is the right answer or no? Now you all of you have to search it. You might have the answers also. So this is uniform intervals means it is not stratified sampling. It is called as systematic sampling. So the answer over here is false again. Okay? It is false. Got it, everyone? Yeah. Second, next one. As a general rule, it is not necessary to include a finite population multiplier in computation for a standard error, the mean when the sampling size is greater than 50. Okay, let me change this. Let me make it when the sampling size is greater than 30. So now give me the answer. As a general rule, it is not necessary to include a finite population multiplier in computation for a standard error of a mean when the sample size is greater than 30. Now tell me the answer. Yes, it should be greater than. True or false? In the comment section, I want the answer from everyone. Is it true or false? Yes, it is. It is true. 30 is a true answer. Okay, 30 is the true answer. This is true. It should be greater than 30. Then the finite population multiplier is not required in that case. Okay, so the minimum sample size is 30 for these cases. Okay, so now before going ahead, everyone, let me tell you, see this. Join our Telegram channel and our YouTube channel using this. Okay, Telegram and YouTube channel, both the channels you should join. Scan this QR code right now over here. Okay, scan this QR code over here. Scan it and you can join our Telegram plus YouTube. Now, what? Why should you join our YouTube and Telegram channel? Why? Why? See, the reason is in these channels you will be getting all the updates. Number one, from this IIBF. Okay, so what is the YouTube channel? Officers Adda 24/7 YouTube channel. Remember, there are many fake channels also. So that's why this QR code is given. By scanning this QR code, you can directly join the LinkedIn, this Telegram channel of this Officers Adda 24/7. Okay. Similarly, for this YouTube channel, you can join this YouTube channel also using this QR code. Okay. So do it fast. Okay. The probability distribution of the means of all the possible samples is known as sample distribution of the mean. Is this true or false? The probability, this question we are dealing with. The probability distribution of the means of all the possible samples is known as the sample distribution of the mean. Is it true or false, everyone? What is it? True or false? This, see here, what are we talking of? Probability distribution of the means of the samples. So we are focusing on the word samples over here. So whenever we are doing the probability distribution of any mean or mode or median, anything for the samples, it is known as sample distribution, or it's called a sampling distribution. That is the right word actually, sampling. But in exam they might give you sample also. Okay, so this answer is again true. Okay, this answer is again true. Got it? Next one. The principles of simple random sampling are theoretical foundation of the statistical inference. What is this? Principles of simple random sampling. So just now what did I tell you? What are the four types of samplings? One is simple random, second is systematic, third is stratified, and last one is this cluster, right? So which one is the best sampling? Base you can call it. Base of any sampling techniques or base of statistics. Among these four, which one is considered as a base? Everyone? That will answer this question also. The principles of simple random sampling are theoretical foundation of the statistical inference. Suppose if I have to find any inference of any population, so for that I need to do the best method is simple random sampling. So that is true. Again, true. Remember, simple random sampling is the best sampling. Okay, is the best sampling. All the remaining ones like cluster or this systematic or this stratified, these come later. But basic is simple random sampling. Okay. So those who are in the paid class, you might have already know. I have explained you what is the systematic, simple random, stratified. Okay. Those are watching on YouTube, kindly join the paid classes, man, immediately, because there we have lot of time, isn't it? Next one. The standard error of the mean is the standard deviation of the distribution of the sample means. See, this we are dealing in. The standard error of the mean is the standard deviation of the distribution of the sample means. Is this true or false? Standard error of the mean I am talking of. Okay. So here we are talking of the mean. Standard error of the mean is the standard deviation of the distribution of the sample means. So whenever I am talking of the mean over here, standard error means what? Standard error relates to samples. Okay. Remember one simple logic. For population, we always use the word standard deviation. And for this samples, we always use the word standard error. So standard error of the mean is the standard deviation of distribution of the sample means. So standard error will relate to samples. So this is again true. These are all information points for you. In exam, you might get such questions. Okay? True. Next one. The sampling plan that divides the population into well-defined groups from which random samples are drawn is known as cluster sampling. So, is this known as cluster sampling? A sampling plan that divides the population into well-defined groups. Well-defined. Well-defined means they can be defined in any terms. They can be defined in the terms of region. They can be defined in the terms of age. They can be defined in the terms of marks. Okay, or they can be defined like in systematic sampling. They can be defined just by serial order. So the sampling plan that divides the population into well-defined groups from which random samples are drawn is known as cluster sampling. So is it true or false? True or false? Is it true or false over here, everyone? It is true. See this, again true. See here, I'll tell you one point over here. Even if this answer would have been instead of cluster, the answer would have been like this. Let me give you 3-4 options over here. If the answer would have been instead of cluster, it would have been stratified. Then, or systematic. Then also the answer would have been correct. See here, well-defined groups means what? Whatever is is it given specifically that what type of well definition? Is it related to regions? Here, I'll give you some hints about this. Cluster will always relate to region. Always relate to region. Stratified will always relate to strata. Means some groups, common things, percentages, 40 to 60%, 60 to 80%. That. Systematic will always relate to line. All of you stand in one line and every 10th person come here. So that is systematic. So these are all well-defined groups. So the answer is true over here. Okay. The standard error of the mean decreases with an increase in the sample size. So as I go on increasing the sample size, will the standard error decrease or will it increase? As I go on increasing the sample size, see, increase in the sample size. So will this standard error decrease or increase? What do you say? True or false? Type fast in the comment section, everyone. Yes. The standard error of the mean decreases with an increase in the sample size. True or false? Let me see. Yes. It is true. That is the basic rule of sampling, right? That is the basic rule of sampling. So the standard error will decrease. What is standard error? Standard error is actually the difference between the population mean and the observed mean. Keep it very simple. So standard error is the difference between the population mean and the observed mean, isn't it? We have that formula z equals to 1 upon psi x bar standard error into x bar minus mu, right? So that formula means that formula gives you x bar and mu. The difference is this known as standard error. Okay. To perform the complete enumeration, one would need to examine every item in the population. Means to do some survey. It's that simple. Suppose if I have to do some survey, so will I have to survey each and every element of the that sample size? Means, suppose if I have been told to find out the average salary in any city, in Delhi, let's say, I have been told to find out the average salary in Delhi. Will I have to take the sample of each and every person in the Delhi? Will I have to go to each and every house in Delhi and ask them, what is your salary? What is this? What is this? Some 5, 6 questions. Is it required to do the survey of each and every element? Not required, isn't it? What do we do? What do we do in this? We take some sample, representative samples. We'll take the samples in the 4 corners of the city, isn't it? 4 corners, various corners of the city, or some 10 samples from various corners of the city, and then we'll find out the average salary, right? So to perform the complete enumeration, one would need to examine every item in the population. So that is false. Okay, you need not do the enumeration of each and every item of the or do the survey of each and every element of that sample. Okay. In everyday life, we see many examples of infinite population of physical objects. So do we see them? We see many examples of infinite population of physical objects. Is it true or false? Infinite population. Do you see them? Give me some example. Give me some example of physical objects. Infinite population. Type in the comment section, everyone. Infinite population of physical objects. Okay, I'll give you some examples. Let me see how many of you have written. Yeah. Now let me see. So it is okay. Can you tell me the number of stars in the sky? These are physical objects. Stars are physical objects. Do you know the number of stars in the sky? No, you don't know, because they are infinite. Suppose if I give you 1 kg of sugar, 1 kg of sugar, and tell you to count each and every grain of that sugar, each and every grain. Is it possible? Grain, each and every grain. Not possible, isn't it? So these are all physical objects and infinite population. We see many examples. That is true. We see so many examples, right? So that is true over here. Next one. To obtain a theoretical sampling distribution, we consider all the samples of the given size. So see this. To obtain a theoretical sampling distribution. Sampling distribution means what is the total number of samples taken, how the samples are distributed. This comes under the normal curve, bell curve we call it. We consider all the samples of the given size. So do we consider all the samples or no? All the samples, everyone? So the answer is true. Yes, we consider all the samples of the given size. See here, sampling distribution, if you have to take, you have to consider all the samples, whichever sampling you have done. Okay, so the answer is true again. Got it? Let me see how many of you have answered this. Yeah. Next one. Larger samples are always a good idea because they decrease the standard error. So if I have the larger samples, will it decrease my standard error? Yes, they will decrease. Just now we saw it in one of the above questions. As the sample size increases, the standard error will decrease. So does it mean I must always go for larger samples? Is it true? What about the cost? Suppose if I am doing a sample survey of 50 persons versus I am doing the sample survey of 5,000 persons. What will be the cost of 5,000 persons? So it's not always a good idea. That is a false answer. It is not always a good idea because cost considerations are very important. In sampling, cost is very important part. Okay. Now before going ahead, everyone subscribe to Officers Adda 24/7 YouTube channel. I gave you the link also. Scan that QR code, okay, and subscribe to this channel immediately. Okay. So in this channel, you are getting all the latest updates from IIBF plus free YouTube series. Right now, what are you watching? You are watching the free YouTube series. So you're getting that also. So that's why subscribe to it. Click on the bell icon immediately. The mean of certain population was 15. Most of the samples we could take from that population would likely have a mean of 15. Is it true? See here, mean of a certain population was 15. So if the mean of certain population, suppose if there is a city and I am having the average salary of that city is 15,000, let's say, okay. So the mean of the samples which I took from all the 5 corners of the city. So will the mean of those samples also be 15 or no? That is, let me see. Okay, let me see first from your side. Are you saying true? It is false. False. Again, the answer is false over here. Why? Because it's not compulsory that the mean of the sample should be 15 only. I'll give you an example. Suppose I'm having the samples here. I took 4 surveys, let's say 4 corners of the city, and I got the average as, means average of one was 10, second one was 20, okay, third one was 15, and fourth one was, let's say 17, okay, and this I'll make it 8. Suppose if I got these 4 salaries, 8,000, 20,000, 15,000 and 17,000. Now you do the addition of all these. 20 plus 8, 28 plus 15, 33, right? 33, then 43, 43, then this 7, 50 and then 60, right? So total I'm getting it as 60 over here. Total is 60. Do the average upon 4. So what am I getting? I'm getting this as 15. So my population mean is coming out as 15, but were all the samples having the mean of 15? No. So it's not compulsory. That is the point I'm stressing. So that is false. The standard error of a sample statistic is the standard deviation of the sampling distribution. So standard error of a sample statistic is the standard deviation of the sampling distribution. That is true. What did I say earlier? Sample standard error is same as the standard deviation. So that is true over here. Okay. True. Whatever this other name for standard deviation is standard error in case of samples. For population, it is standard deviation. Judgment sampling has the disadvantage that it may lose some representativeness of the sample. Judgment sampling. What is judgment sampling? There are 2 types of sampling. One is probability, second is judgment. So judgment sampling has a disadvantage that it may lose some representatives of the sample. That is true. Because judgment is based on the individual judgment. Suppose if I am the judge, I feel something is right, but there may be other things which are out of my purview or out of my thinking, but they may also be right. So that is true over here. Next one. The sampling fraction compares the size of the sample to the size of the population. Now this you must definitely tell me. Let me see. You must definitely tell me this answer. It should be, yeah, sampling fraction compare the size of the sample, size of the sample to the size of the population. So that is, yeah, it is true. That is the meaning of this sampling fraction. Okay, that is true. So that was a session for you. Now before going, let me tell you, we are having the scholars batch for June 24. All the 4 subjects are covered: ABM, BFM, ABFM and BRBL. You can join the Mahapacks 2.0 also. In Mahapacks you are getting multiple batches for each subject. Okay. Plus you are getting ebooks, tests. Let me show you. Let's go to Adda 24/7. Always I will suggest you to go through the app. Okay. In the app you get 1% extra using the point systems. So let's go to Adda 24/7. Look at this. See this here. Once you go to Adda 24/7, click on JIB and CIB. Click on CIB 24. You will see, click on view all. You will see the scholars batch, CIB June 24. Click on this scholars batch. You will get the details of the batch. Look at this, all the details: ebooks, test series, online live classes, then expert faculties, interactive classes, recorded videos, limited size batches. You get everything over here. Plus, look at the fees. Now click on buy now. Put the code Y432. Say this Y432. Here you'll get the maximum discount using this code. Okay. You'll whatever a discount is going on, you'll be getting something extra using this Y432. So apply this code. Okay. Right now you're getting 80%. Then whatever percentage is, you'll be getting plus something. So that's why Y432 is the best, is the code to be applied for highest discounts. Now, one more. You can join the Mahapack also. What did I say about the Mahapacks here? In Mahapack, you get multiple batches, but not only multiple batches per subject. You get test series, ebooks, videos. Click on these ebooks. Check these ebooks. You are getting subject-wise ebooks. Click on this subject-wise ebooks. You are getting chapter-wise ebooks. Similarly for test. In such details you are having per chapter level. We have gone up to the chapter level for this test series. Okay, and ebooks. So click on this test series, again subject wise, right? Click on any subject. You'll get again mock one. These are almost chapter wise now. So such is the details. You are getting chapter wise ebooks as well as tests. Plus you are getting various other details like online live classes, test series, ebooks, experienced faculties. As already I have told you, there are three tenures for this: 3 months, 6 months, and 12 months. So you get double validity right now for using this Y432 also. Okay. So other things also you can check this. The details are given in the course. Details are given over here. You can read those details. Okay. As already I told you, experienced faculties are there. Then revision batches. Revision batches are also available in this Mahapack. Okay. Plus, look at this. You can go through the details. Okay. So I'll always suggest you to join the Mahapack or the batches. Okay, for CAIIB.